When you're asked to simplify and reduce in radical form, the first thing you should do is simplify what you're starting with. If I look at the square root of 80, the square root of 80 is divisible by 16 and 5. The reason I chose 16 is 16 I can simplify. The square root of 16 is 4, so the square root of 80 itself is 4 square roots of 5. So this fraction could be 1 over 4 square roots of 5. If I had 1 over 4 square roots of 5, the rule says we cannot leave a radical in the denominator. We have to rationalize it. So I'm going to multiply both my numerator and denominator by the square root of 5, giving me the square root of 5 in the numerator. When I multiply a square root times itself, this would produce 5, but I still have this 4 here, and 4 times 5 gives me 20. So I have the square root of 5 divided by 20, and that's simplified and reduced. The next problem is not in fraction form, so I'm just simplifying, and I look for something I can take the square root of. I can take the square root of 25. It goes into it 6 times. The square root of 25 is 5, so in simplified radical form, this becomes 5 square roots of 6. Again, I would simplify this square root of 12 before I went any further. The square root of 12 could be written as the square root of 4 times the square root of 3. The square root of 4, though, has a value of 2. So I have 6 over 2 square roots of 3. Even this can still be simplified because 2 goes into 6 3 times. So I now have 3 over the square root of 3. I can't leave a square root in the denominator, so I'm going to rationalize it by multiplying by the square root of 3 over the square root of 3, giving me 3 square roots of 3 over 3. But you'll notice my 3 is both in the numerator and the denominator, so they just cancel out, leaving me simply the square root of 3. Do the following forms right triangles? What they're asking is a squared plus b squared equal to c squared? It is important to recognize that c has to be the longest side in this set of 3 numbers. So I'm going to check, is 15 squared plus 20 squared equal to 25 squared? This is one of the Pythagorean triples that we talked about. It's a 3, 4, 5 triple. 15 squared is 225. 20 squared is 400. 25 squared is 625. Since 625 is equal to 625, then yes, this is a right triangle. The square root of 2 squared plus the square root of 3 squared equals the square root of 6 squared. When you square a square root, there are inverses of each other. They basically cancel each other out, leaving you 2 plus 3 equals 6. Since 5 is not equal to 6, the answer to this question is no, it's not a right triangle. This one also happens to be one of the triples. This happens to be the 5, 12, 13 triple that we talked about in class. But again, to check it, 15 squared plus 36 squared is equal to 39 squared. 15 squared is 225. 36 squared is 1296. And 39 squared is 1521. And since 1521 is equal to 1521, yes, this is a right triangle. Here we're actually going to use Pythagorean Theorem. Notice they said leave my answers exact. So in other words, the square root is still going to be in it, but I'm going to simplify it. Important thing to remember is c has to be the hypotenuse. The other two sides really don't matter. So I have 2 squared plus 4 squared equals x squared. 2 squared is 4. 4 squared is 16. That's equal to x squared. And putting these together, I have 20 equals x squared. And the opposite of squaring something would be finding its square root. So x is equal to the square root of 20. This is exact, but it's not simplified. So I should simplify it. 4 goes into 20 5 times, but the square root of 4 is 2. So in simplified form, x is equal to 2 square roots of 5. When I go to do number 8, I have 3 squared plus x squared equals 12 squared. Notice the 12 is the one across from the 90-degree angle. It's my hypotenuse. 9 plus x squared is equal to 144. Getting the x squared by itself, we're going to subtract the 9. X squared is equal to 135. And the opposite of squaring something is finding its square root. So x is equal to the square root of 135. This is, however, divisible by 9. And it goes into it 15 times. And we can take the square root of 9. The square root of 9 is 3. So in simplified radical form, this would be 3 square roots of 15. When I come over to number 9, I'm going to have x squared plus 4 squared equals 15 squared. X squared plus 16 is equal to 225. And I'm going to subtract that 16 from both sides. And 225 minus 16 is 209. And I'm going to take the square root of that. If I look to see if I can simplify this, there doesn't happen to be anything that goes into 209 that I can take the square root of, so this is my simplified answer. Again, here we're asking, is a squared plus b squared equal to c squared? Make sure that we're identifying the c side. So 8 squared plus 15 squared equals 17 squared. 8 squared is 64. 15 squared is 225. 17 squared is 289. And when I put these two together, 64 and 225, I do get 289. Since 289 is equal to 289, yes, this is a right triangle. When I go to do this one, it's a little hard to tell which side is the C. So I'm just going to square them to start with. 3 square roots of 5 squared. When you square 3 square roots of 5, you're squaring each individual part. So you're taking 3 squared, which is 9, and you're taking the square root of 5 squared, which is 5. And 9 times 5 is 45. I'm going to do the same thing with the next two. 4 square roots of 10 squared would be 4 squared, which is 16, times the square root of 10 squared, which is 10. This is 160. And 6 square roots of 5 squared would be 36 times 5, which is 180. And then I check, does 45 plus 160 equal 180? Because this was the larger side, it had to be the c squared side. And the answer to this is no. This one's easier because we don't see the radicals again. This is the c side. 24 squared plus 45 squared equals 71 squared. 24 squared is 576. 45 squared is 2025. 71 squared, 5041. If I try to add 576 and 2025, I get 2601 is equal to 5041. not a right triangle. Okay, 6 squared, 36. 12 squared, 144. 6 square roots of 3 squared. 6 squared is 36. The square root of 3 squared is 3. And 36 times 3 is 108. So when I'm looking at this, this obviously was my C side. So is 36 plus 108 equal to 144? And the answer to that is yes. 3.6 squared plus 4.8 squared is equal to 6.0 squared. 3.6 squared is 12.96. 4.8 squared is 23.04. And we're going to check to see if that's equal to 36.0. When I add 12.96 and 23.04, I do get 36 equals 36. So the answer to this one is yes, it is a right triangle. Seven square roots of 5 squared. 7 squared is 49. And we're going to multiply that by the square root of 5 squared, which is 5. 49 times 5 is 245. 14 square roots of 6 squared. 14 squared is 196. The square root of 6 squared is 6. So when I multiply 196 times 6, I get 1176. 15 square roots of 3 squared. 15 squared is 225. The square root of 3 squared is 3. And this is 675. Again, this is my C side of this. So I'm going to check to see if 245 plus 675 is equal to 1176. And these are not equal to each other, so the answer to this one is no. Each of these problems deal with one of our special right triangles. Remember that in a 45-45 90-degree triangle, across from the two 45s, we're going to put equals A. Across from the 90, we're going to put equals A square roots of 2. This will always write out an equation. Since A is 9, y would also be 9. I just simply replace the A. X would be 9 square roots of 2 because I can replace A with the 9. In a 30, 60, 90-degree triangle, across from the 30 goes A. Across from the 60 goes A square roots of 3. Notice it's written in my equation. And across from the 90 is going to be 2A. Since A square roots of 3 is equal to 4 square roots of 3, to get A by itself, I would divide both sides by the square root of 3. I don't have to worry about rationalizing it this time because the square roots just cancel out. A is 4, which means y is 4. And if I replace this with 4, x is 2 times 4, which is 8. In the next problem, there's two special right triangles. I have a 45-45 90 over on the right side. I have a 30-60 90 on the left. Across from the two 45s, we'd put A. And across from 90, I'd put A square roots of 2. Since A is 12, then the length of this side in this triangle would be 12 square roots of 2. Now, in the triangle that's on the left, the 30, 60, 90-degree triangle, I'm going to change colors. Across from the 30, we'd put A. So I know a is 12 square roots of 2. Across from the 60, I'd put a square roots of 3, and across from the 90, I'd put 2a. Since I know what a is equal to, I can replace it. Z is equal to 12 square roots of 2 times the square root of 3. I simply multiply my two square roots together, giving me 12 square roots of 6. That's z. If I replace it here, y was equal to 2 times a, so y is equal to 2 times 12 square roots of 2, and 2 times 12 is 24 square roots of 2. In 19 and 20, they are simply asking for the ratio. They want them simplified as a fraction and as a decimal. The sine of a. Sine is opposite over hypotenuse. Opposite of a is 4. The hypotenuse is 5. And 4 divided by 5 is 0.8, or 0.80. Cosine of a. Cosine means adjacent over hypotenuse. Adjacent to a is 3. The hypotenuse is 5. So I have 3 divided by 5, which would be 0.60. Notice they change where I'm starting. I'm going to start at b for tangent of b. The opposite of b is 3. Adjacent to it is 4. Opposite over adjacent is my tangent. This is 0.75.
Mr. Huntley in here?
Yes.
Oh, give him a shot.
The sine of y, opposite over hypotenuse. 24 over 26. As a simplified fraction, they're both divisible by 2, 12 over 13. 12 divided by 13 is 0.92. Cosine of x. Notice we changed where we're at. Cosine means adjacent. Adjacent is 24. Over the hypotenuse, which is still 26. Oh, the cosine of x and the sine of y are exactly the same. 12 over 13, which is 0.92. The tangent of y. Again, down here at the y. Opposite of y, 24. Adjacent to y, 10. This would reduce to 12 over 5. And 12 divided by 5 is 2.4. And I might write 2.40 because they did say to the nearest hundredth. We are going to use a trig function to find our missing sides. Remember, we're going to start at an acute angle. The y is opposite. The 11 is the hypotenuse. And the x is adjacent. If I find x first, adjacent and hypotenuse is a cosine function. So the cosine of 33 would be equal to x over 11. To get x by itself, we would simply multiply both sides by 11. This is what we're going to get keyed into our calculator. And again, remember when you're keying this in on our calculators, they kind of key backwards. We're going to key in 33 cosine times 11 equals. And this should come up to 9.23 rounded to the nearest hundredth. When I go to find y, opposite and hypotenuse is a sine function. So the sine of 33 is equal to y over 11. And I'm going to multiply both sides by 11 to get y by itself. Again, this is what's going to get keyed into the calculator. 33 sine times 11. And this comes up to 5.99. Number 22, we start at the 72-degree angle. The 6 is opposite. The y is adjacent. The x is the hypotenuse. If I want to find x first, opposite and hypotenuse is a sine function. The sine of 72 is equal to 6 over x. We don't solve for x when x is in the denominator, so we multiply both sides by x. I have x sines of 72 is equal to 6. And to get x by itself, we're going to divide both sides by the sine of 72. This is what we're going to key into our calculator. And we're going to key it in. 6 divide 72 sine. And we're going to hit equals, because it won't do the division until I hit the equal sign. 6.31. When I go to find y, that would be opposite and adjacent. That's a tangent function. So the tangent of 72 is equal to 6 over y. Again, we don't solve for y when y is in a denominator, so we're going to multiply both sides by y, leaving me y tangents of 72 is equal to 6. Getting y by itself, I end up dividing both sides by the tangent of 72. This is what we're going to key into our calculator. So we take 6, divide 72 tangent, and we hit equals, and we find out that this is 1.95. In number 23, if I start at the 56, this is opposite, adjacent, hypotenuse. To find x, opposite and hypotenuse is sine. The sine of 56 equals 15 over x. Multiply both sides by x. Divide by the sine of 56. X is equal to 15 divided by the sine of 56. This is what we key in. 15 divide 56 sine equals 18.09. When I go to find y, that's adjacent and opposite.
Mr. Huntley, how are you doing today?
I am well.
Oh, that's good.
All right, pardon the interruption. So here we go. We're going to go find now y. Y is adjacent. Opposite is 15. Opposite and adjacent is a tangent function. The tangent of 56 is equal to 15 over y. We're going to multiply both sides by y. But then to get y by itself, I end up dividing this 15 by the tangents of 56. So I have 15 divided by the tangent of 56. So we'd key in 15, divide 56, tangent equals, and this comes up to 10.12. Here we're going to use an inverse function because we are looking for an angle. We still use the same process. This is opposite, this is hypotenuse. Opposite and hypotenuse is a sine function. So the sine of x is equal to 12 over 13. Notice I left myself a little space here because I know that I'm going to use an inverse function. So I left room to kind of squeeze it in. This is what's going to get keyed into the calculator. To key it in, I do 12 divide 13 equals, and then I hit second function sine, so I'm getting that inverse sine function. And this is 67.3a. But our angles, they said they wanted the nearest whole number, so this would be simply 67 degrees. When I go to find y, the 5 is adjacent. The 27 is the hypotenuse. Adjacent and hypotenuse is a cosine function. The cosine of y is equal to the adjacent 5 over 27. Because I was looking for that angle, I left myself a little space to squeeze in this inverse function. That's what I'm going to key into the calculator. 5 divide 27 equals second function cosine. And this comes up to 79.32. In other words, y is 79 degrees to the nearest whole number.
Charles Crawford, please come to the main office. Charles Crawford, please come to the main office.
Since they are looking for two angles here, I'm going to pick one of them. The 24 is opposite. The 30 is the hypotenuse. The 18 is adjacent. It really doesn't matter what function I use because they've given me all sorts of numbers. I'm going to use sine, I'm going to use opposite and hypotenuse. The sine of x is equal to 24 over 30. And again, I'm going to use an inverse function to find it, so I'm going to use negative sine. This is what gets keyed into the calculator. So I take 24, divide 30, and I use the second function sine button to find out that this is 53.1, which is 53 degrees. If I know x is 53 degrees, I really don't need to use sine, cosine, or tangent to find y. I have 90, I have 53. I've used up a total of 143 degrees out of 180 degrees in a triangle. So if I take 180 and I subtract the 143, I found out my remaining angle would have been 37 degrees, which is my y value. Number 27, a tower is held in place by a 1,500-foot cable. Here's my tower. My cable is the slanted piece. This is 1,500 feet. The cable forms a 32-degree angle with the tower. This is one of those unusual ones. Here's the cable. Here's the tower. And it says the cable forms a 32-degree angle with the tower. Okay? They want to know how tall the tower is, so they're looking for this value. Here's my angle. This is adjacent. This is the hypotenuse. Adjacent and hypotenuse is a cosine function, so I'm going to take the cosine of 32, and it should be equal to x over 1,500. I'm going to multiply both sides by 1,500 to get x by itself, and this is what's going to get keyed into the calculator. So I take 32 cosines times 1,500, and I get 1,272.07 rounded to the nearest hundredth, and this was in feet, so I really should label it. A ladder leans against a wall and reaches 15 feet above the ground. If this is the ground, this is 15 feet above the ground. And it says the ladder is 20 feet long. Well, this is my ladder, and it said it was 20 feet. Does the angle form? What angle does the ladder form with the ground? This is what they're looking for, this angle of elevation. I start at the angle. I have opposite. I have hypotenuse. Since I'm looking for an angle, I do know I'm going to use an inverse function. The sine of x is equal to the opposite 15 over the hypotenuse 20. And I take the inverse sine of each side. This is what gets keyed in. So I take 15, divide 20, equals second function sine, and I find out that this angle is 48.59. In other words, the angle is 49 degrees with the ground. Make sure that you study tonight. go over both sets of reviews. If you can do them, you should be comfortable with what's on the test.